All right. Good morning and welcome to the High Performance HVAC podcast. I am your host, Adam Mufich with NCI. And this morning is a treat. I've had the pleasure of interviewing Steve multiple times in the past with NCI and then also on the HVAC Overtime show. So, Steve is a friend and mentor of mine. Steve, if you wouldn't mind, would you just take a minute or two and, maybe tell everybody your background if they don't know you?
Sure. Yeah, so I'm Steve Rogers. I'm the president of the Energy Conservatory. We're known for the True Flow Grid. We're known for blower doors and duct blasters. We're manufacturer of all those tools, which are helpful when you're trying to diagnose, house as a system kind of problems, as opposed to there's something wrong with just the, within the box, the system itself. And my background is I've been doing pressure and flow basically my whole career. I studied mechanical engineering, and my first job was for an instrument manufacturer in the Minneapolis area that does nothing to do with HVAC. They do instruments for industrial process controls. And that's where I learned a lot about fluid dynamics, about measurements, about pressure and flow, and spent many years with that company before I went to Dwyer Instruments for about a year. Dwyer's in Michigan City, Indiana, just kind of outside Chicago, just around Lake Michigan. And they are, if you're in HVAC, you actually probably heard of Dwyer. So that was very helpful in getting my um, feet wet in the HVAC industry and understanding what they do. And then I moved to the Energy Conservatory, where I started doing engineering and operations management, and eventually bought out Gary Nelson, who's the founder of the company, and then eventually brought on Bill Graber. So Bill and I are the two partners that own the company, and so have had a great time applying many years worth of knowledge to the HVAC industry, to the home performance industry, and helping bring the building science and the HVAC worlds together and helping everybody understand it's one system. The house, HVAC, ducts, it all has to work together or it doesn't work. You can't HVAC your way out of a bad house is sort of where we're at.
Yeah, absolutely. I wanted to, it's funny because every single class that I teach, I tell stories about you and the Energy Conservatory and a lot of your tools and that. And for anyone that is not familiar with me and my stories, but I owe a lot of what I know to you. Like you've spent a lot of time kind of coaching and mentoring me. And I remember one of the big things that really changed the way I did my day-to-day installs and diagnostics and that was Fan Law 2. And I remember I feel like we barely knew each other at the time, and, you offered I was confused about something, you're like, "Well, let's get on a Zoom call,"
Mhm.
and, we sat down and, you showed me the math behind Fan Law 2, and, I just remember at the end of it, I think I actually swore because I was so upset. I'm like, "Are you kidding me?" Like, it blew my mind, and once it clicked, like, man, that was an amazing moment, and then
Yeah.
after that, we went through and I started learning more of the, building science and that, and I flew out to the Energy Conservatory and I took the class with you and Chris, and it was just, man, what an awesome experience, and I really appreciate it, all the time and effort you put into me,
Yeah.
and hopefully it's paying off, you know?
It's been very rewarding. I wear a lot of hats, as the president of the company. But one of my favorite things to do is to teach people. I grew up in a family full of science nerds, and in my family, if you didn't know what you want to be when you grow up, you're going to be a science teacher. And like half my siblings are, in one way or another, are science teachers. And so, teaching people about the science is super rewarding for me, and especially when I get somebody who's as interested as you, Adam, and also who doesn't get scared when you start to say math.
Mhm.
Somebody who actually is interested in learning the math, and the math is not that complicated here, the stuff that we need to do. But it does have exponents, and so you have to remember back to algebra.
Yeah.
um, So that's it's been very rewarding, and it's been a great relationship, and helping me understand what are really the challenges of the technician out in the field, trying to understand what and how can we make tools that make their job easier to get it right.
Absolutely, and I think you guys are killing it in that aspect. I mean, every time a change or an update happens with one of your tools, I look at it and I'm like, "Man, I didn't think that it was possible to make this more useful," but, like, man, it's just, I love seeing the changes. I was actually out, recently, not that this is about, I don't wanna talk about a specific tool, but I was out with a contractor recently, and I was showing them one of your tools, and I opened it up, I'm like, "Well, this is new." And he's like, "What do you mean?" I'm like, "Well, we're gonna learn this together. They updated the app."
Right.
I think it was the day of. So you guys are always making updates, which is really, really cool.
Yeah.
Um, but,
Oh,
today, the whole idea and thought behind this podcast is to talk about duct leakage. And I know duct leakage is getting more and more traction throughout the country and North America and that. And it hasn't in my experience for quite some time. Ever it was kind of overlooked, right? And I want to say I remember thinking back to probably around 2007 or something like that, where I ran into my first situation. Prior to that, it wasn't code to actually seal the ducts in my
right.
area, and so we would just we installed ductwork, we would replace the equipment, and we would just leave the metal bare, all the corners
Hmm.
and that, we wouldn't seal anything. And I remember the first time we had an inspection after that code took place, they failed us, and they're like, "You didn't tape the joints." And I was like, "What? What are you talking about?
Right.
Why should I tape the joints, when the entire duct system, there's no, mastic or tape on anything? What is the point of taping the 5 seams that I have near the equipment?" And
Yeah.
it didn't make any sense to me.
Yeah.
Um
It turns out that's the place to start, because that's the highest pressure in the whole system. It's the highest pressure in the supply is right where it comes out of the cabinet, and the lowest pressure in the returns is right where it goes into the cabinet. And so any leaks closest to the system, those are going to leak the most. The same size hole way out at the register boot is going to leak way less than that same size hole, a foot from the cabinet.
Yeah, so that first 5 feet is crucial, right? And
Yeah.
I
Right.
think that actually, the first time I think I heard that was from, a friend of both of ours, which I just had the privilege of going out to his job site, is Doug Crawl, and he
Oh,
was basically saying that when he has a duct system he's trying to seal, an existing system, he starts with the equipment and moves further out. So yeah. Um Doug, the job that he just did, Chris actually just challenged Doug on this job site. He challenged Doug and he said, "Listen, Doug, I know you get down to really low leakages, but I want to see if you could economically seal a duct system with tape only."
hmm.
And Doug's like, "Hold my beer," you know?
Yeah, right. And Doug will do it, and Doug's in Chicagoland. A lot of Midwestern techs are like, it's all inside the house. It doesn't matter. Why do I care? Doug knows why it matters. And Doug knows how to seal them.
Yeah, do you wanna talk a little bit about that? Like, why does it matter? Because that's a huge every time I talk to somebody in the Midwest, they're like, "It doesn't matter, we're not losing any heat." It's making its way into the house anyway.
Yeah. So that is really true. That's not incorrect. And so before I dive into why it's a problem in the Midwest or wherever ducts are inside conditioned space, I will say when they're outside of the building or outside, in the attic or in the crawl space, it's definitely worse. But let me describe what happens when you have a Midwestern duct system. They're all in conditioned space, and you have duct leakage. So it turns out that everybody in the Midwest thinks, oh, basements are just cold in cooling season, right?
Yep.
You can't get the basement to not be overcooled. Well, if you start looking at the numbers a little bit, we're gonna let's talk about a 2.5 ton system that's moving exactly 1,000 CFM just because it'll make the math easy, right? Um, a duct system that has no tape, no mastic anywhere is probably leaking about 25%. So 1,000 CFM and you're leaking about 250. Um, and if you've done a load calculation of a house that has a basement, you know how little cooling load there is in the basement. It's typically like maybe 10%, usually closer to 5% of your cooling load is in the basement. And in a single story home, the ducts are in between the basement ceiling and the main floor. And if that basement is finished, which lots of them are, that's why you care if it's too cold down there, is because it's finished. Then the air leaks out. You're losing 250 CFM. But let's think about that. So we know that's 25% of our 1,000 CFM, but 250 CFM, that's like more than you would put in the living room, right? With a big window. It's like maybe the living room plus the dining room and maybe part of the kitchen. That's how much 250 CFM is. That's how much cooling you're delivering to the basement that doesn't need it. So the only way to get the cooling to stay where you need it is to seal the ducts. You could like hermetically seal off the registers in the basement, but if the ducts are still leaking 25% of the air, then you're still putting too much in the basement. And that's why it's too cool. I learned this on a personal level when I had an aeroseal done on the ducts. I had a 1958 single level ranch style house in the Minneapolis area. And, the basement was always overcooled. And I did a few things, like there was a duct that wasn't even attached, and there were some register boots that like are hovering like an inch away from the sheetrock. So
Hmm.
when you close the registers, it just blows all of it into the floor cavity. And after the aeroseal, I was able to keep the basement within a few degrees of upstairs. And because my basement was pretty full and there was really only one window that got any sun at all, really in reality, the load in that basement is probably negative. So
Mhm.
even if you could deliver 100% of the air upstairs, it would still be a little too cool. But what I found is just putting a portable dehumidifier in the center of that area under the stairs, it was enough to just, the dehumidifier kicked out just enough heat to make it exactly the same temperature upstairs and down. But even without the dehumidifier, it was probably within 2 or 3 degrees cooler in the basement. Whereas before sealing the ducts, it was like 7, 8, 10 degrees cooler in the basement. So the reason that basements are cool is not because, well, that's just how it is. That's just how they work. It's because the ducts are too leaky to put the air where you need it. And so that's an example of why leaky ducts matter, even in if they're inside conditioned space. Um, Same thing is true trying to get the system balanced. NCI has done a great job educating people about flow hoods and balancing the system, delivering the airflow to the correct places that you need it. So even if you get the duct system 100% balanced, if 25% of, we'll just say in heating season, if 25% of the air is going into that floor cavity somewhere, I don't know where, is it under Susie's bedroom? Is it under the living room? Well, you've got, again, a living room's worth of heating capacity going into the floor and you don't know where. So even if you do a perfect job of balancing all the bedrooms, wherever there's less leakage under the bedroom, it's going to be colder. That room would need a lot more air because there's a large percent of the capacity is just leaking into the floor cavity.
Yeah, and that's, I mean, when you have duct leakage too, it's not like you can't balance something the way it was designed. It's like you have to proportionally balance it, right?
Yeah.
That's the only way you could possibly do it. And when you have 30% less air, and you start looking at what your target design airflow is to each room, and then what your new design based on your duct leakage is, you're like, well, it's substantially less. Like you're delivering
Yeah.
substantially less all over. And like you said, if you are dumping a bunch of air under one room, that room might be comfortable, but you're wondering why the other bedrooms are not comfortable.
Yeah, that room that has a bunch of leakage under it. I mean, let's say, in newer homes where they like to put the HVAC system off on one end of the house. Well, that's where all the leakage is going to be. That's where the pressures are highest. So if you're leaking a living room's worth of heating or cooling into the floor cavity on one end of the house, you really need to be delivering probably twice as much as what Manual J would tell you, room by room, to the other end of the house, because there's no, you're not getting that like bonus leakage heating and cooling that's coming from the floor.
Right. And you said, it's a strong likelihood that in an unsealed duct system you have 25% leakage. I have found that, which not measuring with a duct blaster, but in the Midwest, a metal trunk and branch system with multi floors, so basement, first floor, second floor. Um, Usually, where I'm at, I would do it like what you would call maybe a live duct leakage test, where you would measure the fan airflow at the equipment, and then you would measure, which I know it's not 100% accurate, but measure the delivered airflow at each one of the supply registers with a nice capture hood. Um, I typically found that we were at between 30 to 40 or 30 to 35% average leakage.
Yeah, that
So
and that's so I'd call that an operational duct leakage test, and it's important to do those as long as you understand the limitations. So, what you should understand is when you do a duct blaster test, the leakage number that you get doesn't correlate to how much is leaking when the system's in operation. And so let's talk about what's happening when I do a duct leakage test versus, or sorry, a standard duct leakage test or standardized with a duct blaster versus what we might call an operational duct leakage. And operational duct leakage is just like you described. You want to measure the total system airflow going through the cabinet with a true flow grid, for example. That's about plus or minus 5%. And then with a really good flow hood, you're measuring each of the supply registers, add all those together. And that number is also going to be in the order of plus or minus 5%. So let's use our 1000 CFM example. So the uncertainty on the true flow measurement through the cabinet is going to be about plus or minus 50 CFM if you measured 1000. So let's say your flow hood's measuring 800, or sorry, your flow hood adds up to 800. So you got 200 less. That's going to be 800 plus or minus 40. So I got plus or minus 40 on the flow hood and plus or minus 50 on the true flow. Worst case is 90, but statistically it's going to be more like 70. So is it useful to have a number that's plus or minus 70 on that house? I would say yes, it's definitely useful information, but you're not going to do that for a compliance test because compliance wants a 2,000 square foot house to be less than 80 CFM. And you don't want to, you don't want to be doing 80 CFM plus or minus 70 CFM. Whoever's trying to pass code
yeah,
would not be happy with that.
I think the whole thing is though, like when you're doing this type of test, you're kind of most of the time it's an existing home and you're trying to battle like a comfort complaint. You're trying to
Yeah.
figure something out. So like if you have 300 or 350 CFM of leakage and it's plus or minus 80
70.
CFM, it's
Yeah.
like,
Yeah.
well, no matter which way I go, it's either bad or it's worse. And it's
Yep.
you know what I mean? So we know we have a problem. All we're doing is like figuring out we have an issue
Yeah.
and identifying that we need to address that issue, right?
Right. And it's very useful because if you're trying to solve a comfort complaint, air balancing the system is something you want to do anyway, right? So I need to know, am I getting the CFM that my room by room load calc is telling me I need in Susie's bedroom into Susie's bedroom, number one. And then by subtracting from my true flow, I can get an operational duct leakage. And that operational duct leakage, like I said, it doesn't it'll be related to the standardized duct leakage, but it won't tell you the same number. So having been through that, understanding that it's a useful test, especially when you're trying to find large amounts of duct leakage, because like you said, I'm trying to find 250, 300 CFM of duct leakage. Do I care if it's plus or minus 70? It's still useful for sure. But now let's look at what we do when we do a standardized duct leakage test. So if you're doing a duct leakage test for compliance on a new home, the standard in most states is 4 CFM per 100 square feet of floor space. So let's make the math easy again. 2,000 square foot home to pass code has to be less than 80 CFM. So you take your 2,000 CFM, divide by 100, and you get 20. 20 times 4 is 80. That's where you get your 80 CFM of duct leakage. That's your maximum that you can have and meet code.
Now, is that with or without the equipment installed? Because isn't there a different metric?
Yes.
Okay.
Yeah. So if the cabinet is installed, it's 4. If the cabinet's not installed, it's 3. So on that 2,000 square foot home, you'd have to be at 60 instead of 80 if the cabinet's not installed yet. So what they're saying basically is that the cabinet's going to leak about 20 CFM, which is true. That's a good reason to learn how to seal a cabinet as well. Maybe you don't want to do that with tape and gray mastic. Maybe you want to do it with clear silicone so it looks nice, for your pretty install. But, hook up a smoke generator and find out whatever brand of furnace or air handler you sell, find out where it leaks. You're going to find some big ones and learn how to seal those up. It's just going to make everything work better.
Yeah, I was actually wondering too. I mean, like to get sidetracked for a second, but the equipment in general, obviously, air handlers, furnaces, they all have their leak points. In between were the two, the blower compartment and that upper burner compartment. You're going to have some leakage right there. I was kind of wondering. I actually had a conversation with Doug last week when I was out with him. Do you think that the heat exchanger leaks, that you could have some leakage through that heat exchanger since that's not hermetically sealed as you test the system?
Yeah, there's some leakage. I've measured a couple of them with a device we have for measuring really tiny leaks. They do leak some, but it's really small. I think I was measuring in the order of like 0.1 or 0.2 CFM.
Okay. So not anything to worry about. Okay.
Yeah. Well, and it's under negative pressure, so it's not that combustion gases are getting into the house.
Right.
It's the air from the house. A little bit of the air from the house goes into the combustion and out the flue.
Okay. So back to that 2,000 square foot house. We're looking at the compliance testing. We have the equipment in place, and we're shooting for 80 CFM.
Yep. So the way that we do that test is we need to seal up all the intentional holes. So all the supply registers and all the return registers get sealed up with masking. We do it's a plastic duct mask. It's similar to the carpet protector film you've seen at construction sites. So that gets used to seal off all the supply registers and all the return registers. And then you connect the duct blaster system up to either a large return if you have a central return, or at the cabinet if you don't have a central return. And then the duct blaster is going to pressurize the whole system to 1/10 of an inch of water, or 25 pascals. That's just the standard pressure that was picked for doing duct leakage test. And then it measures how many CFM are leaking out of the system when all the intentional openings are sealed up at 1/10 of an inch of water. And that is the number that has to be less than 80 CFM if it's a 2,000 square foot house. And the reason the test is done that way is because, just like I explained, the operational leakage test is probably more important to solving comfort complaints. But who wants to be the HVAC installer that failed 80 CFM with a test that was plus or minus 70 CFM? You'd never accept that.
Right.
And so what we do instead is we seal up everything. We bring the ducts to a standard pressure. It's like, it doesn't matter if you're operating at higher than that or lower than that. We're going to do them all at 1/10 of an inch of water in the whole duct system, which is probably lower than the part of the duct system that's near the cabinet. And it's probably higher than the part of the duct system that's near the register boots at the end of the line. So it's in the middle there somewhere. And we're going to test them all at that condition, because then it's kind of a level playing field, right? if you're designing your system well, we just care about how many holes are in it and how many CFM come out of those holes. And that test, we can measure the leakage plus or minus like 3%. So now I'm measuring, 80 CFM plus or minus a couple of CFM, not 70 CFM.
Right, and it's that, 25 pascals and, which is equal to zero point 0.1 inches of water. The whole point of that, well, number 1, for, a gas heating system, a gas furnace and that, like, zero point 0.1 is a pretty ideal duct pressure, right? That's, like,
Yeah.
what most people should be shooting to achieve if possible.
Yeah.
Um, but also it's creating a level playing field for everyone. It's a compliance thing to create a level playing field, so
Yep.
you might have, really high static pressure or really low static pressure in a duct system, but it's just making it equal for everybody out there.
Yeah.
I wanted to ask you about this though, like depending on where you connect a duct blaster. So if you have a central return that's on the opposite side of the house, let's say it's, 30 feet from the equipment versus connecting it at the blower of a furnace, right?
Yep.
Um, Now we know that the pressure is always highest near the fan. Depending
Yep.
on where you connect to your duct blaster, can you measure different amounts of leakage?
Yes. So let's take your example. So we have the duct blaster at one end, and where the filter grill is, we've got a system that's got a filter grill that's far away from the air handler cabinet. That doesn't happen super often, but Joel Becker brought to our attention that that happens a lot in um, package units. They'll put the package unit outside the house over here, and then they want the filter in a convenient place in the house, and there's just a huge flex underneath in the crawl space. So it does happen, and here's what you need to keep in mind: the pressure is highest near wherever the duct blaster is, and it's going to get lower the farther away that you get. But if you're passing that test with 80 CFM, remember we're now blowing 80 CFM or less through a duct system that was designed for probably 1,000 or 1,200 CFM. What that means is that the pressure loss from where the fan is to the far end um, is really small.
Mhm.
And so in a system that's passing, you can do this, and you should do this just to learn for your own knowledge. Put the pressure probe for your duct blaster test, put it in the supply register that's closest to where you're connecting, and then get a long tube and move it to the supply register that's the farthest from where you're testing. And you'll find that if you're doing a test where you're passing the test, you're going to find that the pressure is almost the same. It's within probably a pascal or two. But if you're testing an older home and you're not doing this for compliance, you're doing this to understand where the leaks are and how much the leaks are. Now you can be in a situation where you might be leaking 500, even 1,000 CFM or more. And now it starts to matter, where do I put the probe? Because if I'm now moving 1,000 CFM of duct leakage in a duct system that was designed for 1,000 CFM, now the pressure loss from where the fan is to the far end of the line is significant. And so you can put your probe in a test like that. If you test a house that's leaky like that and find out, oh, it's 25 pascals near the fan, but it's only like 18 at the far end, or maybe even less.
So that loss or that change in the amount of leakage is relative to the total leakage in the system or the total openings, I guess,
Yeah.
that you would have
Yeah.
in a system, how bad the duct system is constructed or how
Yeah,
poorly,
exactly.
right?
And so what I recommend that you do for a system that is really leaky like that, I would just put it somewhere in the middle. I mean, you're not passing or failing this for compliance, and so you just want to have some idea how leaky it is. Um, and that, am I leaking 500 CFM or 1,000 CFM or 1,500 CFM? Let me bring up an interesting point that a lot of people make or they get really curious about, because this uh, it sounds inconsistent. It sounds like, why would you even do that? It's definitely possible to measure more duct leakage in a system than the air that it moves. So in a 2-ton system that should be moving about 1,000 CFM, could you measure 1,200 CFM of duct leakage? And the answer is yes, you could. Usually that happens when, in the Midwest, those of us in the Midwest or the Northeast, we've all seen floor registers where the boot's not even attached to the subfloor. And there's a 1-inch gap between the boot and the subfloor. Well, when you tape over the floor register and seal it up perfectly to the flooring, there's still a giant leak between the boot and the subfloor. Or the same thing can happen between the boot and the sheetrock if it's a sealing register. And so those are the systems that leak, thousands of CFM. And what that means is that the unintentional openings in that system are way more than the same order of magnitude as the intentional ones. And so it doesn't mean that in normal operation, there's 1,200 CFM coming out of the leaks. It means that if the whole system's at 25, there's 1,000 CF or 1,200 CFM coming out of the leaks, but it's not. At those register boots where you have the enormous leaks, it might really be at 10 pascals, not 25 or even less. And so those giant leaks at the boot are a huge problem, but they're not actually leaking 1,200 CFM.
So let's unpack that for a second. The way I like to think about it is, and if you guys envision like a duct system, right? I like to think of like total external static pressure is the sum of all pressure losses or pressure drops in a duct system, right? So as you go through, if you have a trunk and branch system, every fitting, you're going to have a drop in pressure across that fitting. Every turn, every section of duct, it's going to, your duct pressure, your static pressure in that supplier return duct is going to continue to drop and until it's at the lowest point inside of the system, which is right before that supply register or return grill, which is going to be the lowest pressure. So what you're saying right now is if we maintain, and if it was possible, if we had the same duct pressure throughout the entire system, the leaks would be tremendous and it would be awful. But in reality, that would be a compliance thing. Because of where those leaks are located, further out in the system, we're not noticing those leaks because the pressure is so small.
Right.
Okay.
And then, you can ask yourself the question, well, when that system is operating, how much of the air is coming out the register and how much is leaking, behind the, under the subfloor or, behind the sheetrock. And it's really hard to know because it depends on how sealed up is that space and a bunch of other things like that. But what we can say, it's not all going into the room.
Yeah, absolutely. So we've been talking a lot about ducts inside of the house, right? So Midwest, that's where me and you are from, and
Yep.
we have our trunk lines for the most part in the basement. Once in a while, you have a second floor addition or something where they put the duct system up in the attic. But there are parts of the country where all of their ducts, 100% of the ducts are either in an attic or a crawl space, and they're outside of the conditioned space. So, in order of magnitude, we said, you made a point to say that duct leakage does matter inside of the house. So let's talk a little bit about outside.
Yeah. So when the ducts leak to outside, it's definitely a worse situation. Doesn't matter if you're leaking from suppliers or the returns to outside, it's always bad. And let's walk through this. This is a little bit difficult without graphics, but I'll try and do this as a, think about what's happening here. So we're going to take our 1,000 CFM system that we just talked about. And let's say that the return is in a closet. So and the duct system's in the attic. So the air handler is in a closet, returns in that same closet. So let's assume that that closet's been sealed up properly. So there isn't any return leakage in this house. And but the supply ducts are in the attic and they're typically leaky, we'll say. So again, 1,000 CFM comes out of the air handler. It goes into the duct system. All 1,000 are making it into the attic. But because of those leaks, let's say there's 200 CFM leaking into the attic. So now there's only 800 CFM coming back into the house. So what's happening in the house if the air handler is sucking 1,000 CFM out of the house and it's only putting 800 CFM back into the house? Where's the extra 200 CFM coming from? And if you think about this for a minute, you realize there's only two things that could possibly be happening. The first one is that if you keep over time taking more out than you put back in, then the pressure of the house will just keep getting lower and lower and lower and lower and lower until it implodes. Well, we've never seen a house implode because of duct leakage. Okay, so that doesn't actually happen because the fan doesn't have enough power to do that. But here's what does happen. The air gets made up from somewhere. So the pressure in the house does start to get lower and lower. And as the pressure in the house gets lower, it's sucking in more and more air from outside. Every single leak in the house now is drawing air in from outside to make up the missing 200. And at some pressure in the house, it will get low enough to now the house is sucking in exactly 200. And so now the system's back in balance. You get 1,000 CFM going out, 800 CFM coming in from the supply registers, and the extra 200 is now coming in from all the leaks. So, and this is kind of like a self-balancing system. And the pressure in that house is just going to keep dropping until it sucks 200 CFM in from outside. Okay, so let's talk about the two separate effects that happen because of that imbalance in pressure. So I'll give a little history here. This pressure imbalance that's happening was called mad air when it was discovered. The first two guys that popularized this were Neil Moyer and John Tooley, who are both still around, both of them great guys. They call it mad air, which stands for mechanical air distribution. So that's your blower, fan, and duct system, and interacting relationships. So like what happens when there's leaks. So another way to think about it that's maybe a little easier to remember is there's a pressure imbalance in the system. And so what happens when I've got 200 CFM coming in from outside every time the system runs? Well, that causes your load to be a lot more than Manual J told you. Manual J doesn't know you have a huge duct leakage problem and that there's a pressure imbalance in the house. So typically, a house might have maybe 50 CFM of leakage if the duct system were sealed. So the house is going to leak anyway without an imbalance from the duct system. But when you add the duct leakage, it gets a lot bigger. So Manual J does include infiltration through the building envelope. But when you add the pressure imbalance, you might double it, you might quadruple it. And so whatever that line in your Manual J that says infiltration is, however many BTUs that is, that might be only a tiny fraction of what the real situation is because of your duct leakage. And that part of the load is important because if you're drawing in way more outdoor air, cooling season in a humid climate, the sensible BTUs are significant. But what's even more significant is all of the latent load you're bringing with it if you're in a humid climate. And a lot of people don't think about the reverse, which is duct leakage to outside in a colder climate, because it does happen. Across the Northeast, there's a lot of attic systems. Even in the Midwest, we got ducts behind knee walls that are in an outside attic. And the same thing happens if you're drawing outdoor air in the wintertime, or it's not the same thing. The opposite thing happens, which is you dry out the house rather than bring in moisture in. You're letting all the moisture out. You can't keep it humid, even with a good humidifier, because you're just sucking all the dry air from outside in and letting the supplier go out. So that's the more severe thing that happens is, bringing way too much outdoor air in, affecting the load. The other thing that happens is much simpler, and that is simply that if I've got 1,000 CFM and 200 didn't make it into the house, I just lost 20% of my capacity. So now I've lost 20% of my system's capacity, and I'm trying to cool or heat a load that's bigger than I thought. And so this will explain why the system can't keep up, not because it was undersized. The manual J might tell you the system was sized perfectly, but because the duct leakage to outside is killing you twice, you lost the capacity by blowing it straight into the attic, and then you increased the load because you were drawing outdoor air in. Now the system really can't keep up. It's undersized for the real conditions, even if it were correctly sized, if the ducts weren't so leaky.
Yeah, I like to think of it like, as the air is being cooled or conditioned, that air in the duct is expensive air.
Yeah.
You've paid to condition that air. So let's say for every dollar you spend on conditioning the air, if you have 20% leakage, 20 cents out of every dollar you spend is being blown into the attic or blown outside.
Yeah.
So that's a pretty significant loss, right? And
Yeah.
you made the point to say that, and I think I've heard you use this comparison before. You call it a double whammy. It's
Mm-hmm.
like a double penalty, right? You're losing the capacity of your system. You're essentially losing 20% of the equipment's capacity because you're blowing that air outside. And then the house is becoming negatively pressurized, which means you're sucking in the outside air, creating a higher load. That's
And that, let's use the dollars again. So it might be that you're just blowing 20 cents of every dollar out your attic vents, but now you also have to pay an extra 20 cents because you're bringing outdoor air in. So you might actually be losing closer to 40 cents out of every dollar you spend on heating or cooling. Um, it depends on several things, and whether your supply leaks and your return leaks are exactly balanced or not exactly balanced. But the two effects are about the same size. So if you
Mhm.
lose 20% of your air, you're probably going to lose another 20% by increasing your load.
That's wild. So one of the things I was actually just working on a project. I'm still not done with it yet, but I'm writing up a tech tip, and the whole thing was we're looking at ways for somebody to easily identify duct leakage and different methods like screening, not necessarily a test, but like a
Yep.
scratch and sniff type deal.
Yeah. So because duct leakage, we explained how that's done. You mask off all the supplies and all the returns. That's a fair amount of work, and that's not something you want to do if you don't have a kind of a smoking gun or you don't need to do a compliance test. So there are some screenings that you can do. The simplest one for an HVAC technician that requires only a micromanometer. So if you've got a DG8 manometer for your true flow, you can do this test. You don't need any other equipment. And Adam's written a good tech tip. I think it's going to be published soon that explains the step by step. But basically, what you're doing is you're measuring the pressure between indoors and outdoors. So you're going to put a tube out through the door, and then close the door in a way that doesn't kink the tube. You can use a probe for this. And then you measure the pressure in the house with all the HVAC turned off. So clothes dryers off, exhaust fans are off, range hoods off. Anything that might blow air outside is off. You just measure the pressure. It's not going to be zero because the temperature inside and outside are different. So it'll be a little bit positive or it'll be a little bit negative. Measure that pressure, kind of watch it, make sure it's stable, and then turn the HVAC equipment on and make sure it gets to full fan speed. And you measure that pressure again. And if the pressure if it goes negative, so let's say you started with a plus half Pascal, that would be a typical pressure, plus 0.5, and it goes to -2, that means you moved -2.5. And if your pressure moves in the negative direction, that's because you have leaks from the supply. And that's exactly the situation we described before, where supply ducts are leaking into the attic and you have to make up the air by drawing it through leaks in the house. If the number goes positive, so let's say again we started at +5 or plus 0.5 rather, half a Pascal, and then when you turn the HVAC on, it goes from plus zero point 0.5 to +2. That moved 1.5. It went positive by a Pascal and a half. That means that you have return leaks. So when you have a filter grill in the hallway ceiling, if that's not all sealed up between that filter grill and the cabinet, then it can be drawing air into the return from the attic. And that will cause, if there's more leakage in the return than in the supply, then the house will go positive pressure when you turn the HVAC on. So this is called a dominant duct leakage test, and it's a super useful screening to just see, is something going on with leakage in the attic or the crawl. The thing to remember though is it doesn't measure all the leakage. It only measures the difference between supply and return. So whichever one is dominant, whichever one has more leakage, that's what's going to change the pressure in the house. So if I have 200 CFM leaking into the return and 300 CFM leaking out of the supply, then that's going to behave the same as, so that difference is 100. There's 100 more going out the supply than coming in the return. That's going to behave like 0 leakage on the return and 100 CFM on the supply. So it's the difference that will drive the house pressure different. But if those are both leaking significantly, you might think it's not that bad, but it's really bad because really there's 500 CFM of leakage, but it might behave like there's only 100.
Right, I think it's important to understand there's limitations behind it, and,
Yeah.
like, in your example where you talked about there being a little bit more leakage on one side versus the other, and if
Yep.
you just use that screening to say, "Okay, well, I'm gonna attack this side and seal up this side of the system," and then once you do that, you go back and like, "I fixed the problem." You do the test over again, and now you see it swing the opposite direction,
Right. Yep. Yeah.
so
So there's when you do the dominant duct leakage test, um, there's 3 results. If it goes positive, that's return leakage. If it goes negative, there's supply leakage. But what if it's near 0? Or we can't tell if it's near 0 because it's kind of a windy day. So there's 4 possible interpretations, and only one of them's good.
Mhm.
And here's what the 4 possibilities are. It could be that there is very little supply and very little return leakage, and that's the only positive interpretation. There's not much leakage. Awesome. Did your job. But the other possibility is it's a very leaky house. And so even with supply ducts or return ducts that are leaking a lot, the house is so leaky that it doesn't create a big pressure difference. It's moving a lot of air through the house envelope, but with very little pressure because it's leaky. There's just tons of holes in the house. So that's not a good result either, but that could be the reason you get 0. The other possibility, as we talked about before, is it could be that your supply and your return are leaking about the same amount. And so neither one's dominant. That's not a good thing. That could be very bad. And then the fourth interpretation is that it's a windy day and it's bouncing around so much, even with the HVAC off, that I can't really tell if it's changing when I turn the HVAC on. Because on a windy day, you could see, the house pressure could be bouncing around easily 10 pascals. And, you're not going to find 2 pascals if it's bouncing around 10 pascals.
Mhm.
And so you just have to wait for a calmer day to do the test.
Is there any way around that? Is there any kind of tool or device you could do to shield the wind? Or is it
Not so much shielding the wind, but a better way to do it would be to just repeat the test over and over and do averaging.
Mhm,
So if you, with your DG8 manometer, you can connect that to our app, and then you could do like 10-second averages over and over. So I could do, 10-second averages. I'm going to take 5 of those, and then I'm going to turn the HVAC on, and I'm going to do 5 more 10-second averages. You know, average those averages all together, because the app will record and do the average for you, and then see if there's a difference. A lot of times you'll see it bouncing around, but once we start doing averaging, we can get that noise out. It depends on exactly how leaky it is and how patient you are. If you have to do 10 averages 10 times, most people aren't going to have the patience for that.
Yeah.
And so that's, you can do averaging is the best way to do that. And that would mean that you're turning the system, the HVAC system, off and on and off and on, and you're taking an average of it on, average of it off, average of it on, average of it off. And then each time you're averaging those together to see if there's a difference. So that's the best way to deal with wind noise. Most shielding doesn't work, other than, I should have mentioned this. The leeward side of the house has way less wind noise. So if the wind's blowing from the west, the leeward side is the east. So whichever side is away from the wind, that's where you want to put your probe. You might find 3 or 4 times as much noise on the windward side as on the leeward side. So that's one thing you can do. And if you can't get it out the door, there's usually a window on the leeward side, or you can even run the tube, around the side of the house, from inside around the side of the house to whichever side is leeward. So that's ways that you can deal with wind. Not always practical, but you can do it.
Is there any other type of tests like screening, easy tests that somebody can do?
Yeah. So the other type of screening you can do for leaky ducts is a pressure pan test. This would be done if you're already going to do a blower door test. While you're running the blower door and you have the house at 50 pascals, you take a pressure pan, which is basically just a big plastic pan that you connect a pressure tube to, and you seal that over each of the supply registers. If the system is tight and you have the house at 50 pascals or minus 50 pascals, well, then the pressure in the duct system and in the house is going to be the same, and you'll measure 0. Okay. But if there's leaks in the duct system, then the duct system could be at a lower pressure than the house. And so when you put a pressure pan over a supply register, you'll measure a pressure that's greater than 0. And that tells you that you're near a leak. This is also a good way to find where the leaks are. If you pressure pan the entire house while the blower door is running at 50, whichever supply register has the greatest pressure pan measurement is closest to the biggest leaks. So this is a good method for locating leaks as well as for screening. We can't tell you exactly how many CFM is leaking with a pressure pan screening, but it's a good way to detect. And a lot of people will say, as long as it's under about 2 pascals, 1 pascal, you've got a pretty tight duct system. And, but if you're measuring 5 pascals, 10 pascals when you do a pressure pan test, then you know that you got a pretty leaky system, and it can also help you locate where the biggest leaks are.
I've excuse me. I've played around a lot with the blower door too, and one thing that I've noticed is that certain houses, I think, if it's so bad, you don't even really need a pressure pan. Like if you hook up a blower door, you could actually feel airflow coming out, like kind of blasting out of it feels like the HVAC equipment is on. There's so much leakage, right?
Right. Yeah.
Which is wild because you're like, what is, and you don't really know what that means. You still don't know what it means. It's not like it's a measurable number, but like if you feel air blasting coming out of the register, it's not a good thing with the blower door running. Right.
Right. And so that reminds me of another kind of simple diagnostic test that you can do. Even a homeowner can do this. My sister lives in North Carolina, and they've got a 3-story house that's over a crawl space. So a lot of stack effect there in the wintertime. And she said, my main floor over the crawl space just gets, deathly cold. And I said, go over to a supply register, and when the system's off, do you feel cold air coming out? Because the stack effect will do the same thing as the blower door, where if your ducts in the crawl space are leaky, just the stack effect will draw cold air in through the ducts, and you'll feel cold air coming out of your registers whenever the system is off.
I've never thought about that. That's pretty cool.
Yeah. If the ducts are sealed up well, then you won't feel any air coming out when the system is off.
Hmm. That's wild. So, one other test I wanted to bring up, and I know the first time I ever saw it was when I visited you guys the first time at your old headquarters at the Energy Conservatory. But you guys had a rig to show us, like, just in your warehouse how to do this. And then I've
Yeah.
used this multiple times in the field. But I think one of the coolest tests, if you have the tools and the ability, one of the coolest tests you could possibly do is the duct leakage to outside test.
Oh, yeah. Yeah.
You
So
want to
we
talk a
now
little bit?
have, yeah, we now have a training house that we can set up to do this test. It's a 17 by 18-foot house inside our training center, built like a real house, looks like a real house. And so the way that the duct leakage to outside test is done is similar to a total duct leakage. So you mask up all your supplies, you run your duct blaster, you bring the duct system up to 25 pascals, but then you also put a blower door in the front door and you bring the house also up to 25 pascals. So if my ducts are at 25 and my house is at 25, then the difference between my ducts and my house, at least the ducts that are inside, is zero. Okay. But my ducts that are in the attic, they're still at 25. And in the attic, well, hopefully the attic is at zero pressure when you're running a blower door. And so what this does is, let's say you measured 200 CFM of leakage for your total duct leakage. And then I start up the blower door and I bring the house up to 25 pascals, same as the ducts. Now my 200 CFM of total leakage, maybe it goes down to 150. That tells me that 150 of my 200 is leaking to the outside, and the other 50 CFM is leaking somewhere inside. Because when I balance the pressure between the ducts in the house and the house, then those leaks stop leaking, or at least they get really close to zero. So, yeah, duct leakage to outside, and I think there are some states where it's been required in the past, and it's, it sounds like a complicated test to do, but if you're there to do the compliance testing, you have to do a blower door anyway, and you have to do a total duct leakage anyway. It's gonna take you like an extra 4 minutes to do the duct leakage to outside.
Yeah.
Um,
And
so
it's really, really cool. Like, if you think about it, I mean, you just said what is happening? You're essentially, the leaks that are inside the house, you're plugging those leaks with air patches of
yeah,
air.
yeah,
Just, you're pressurizing them, so, like, you're isolating just the outside leaks in the attic or wherever those leaks occur. So, you could see how bad that duct system is, and that's really what's gonna drastically impact a system when all of your ducts are outside. Is, I mean, we also talked about how important it is duct leakage on the inside, but what's
hmm
gonna make a monumental, impact on the comfort and the efficiency of that system is duct leakage to outside. You wanna start there,
yeah.
right?
And I would do a duct leakage outside, even in the Midwest. If I've got a system that's got a half story or has a bonus room over a garage, a lot of times those ducts are behind the knee wall. They're in that little triangular attic behind the knee wall. And if I think I might have a problem and I've got to do a blower door in this house anyway, maybe I'm going to do a duct leakage to outside as well, because I need to find out, okay, well, I know it's leaky because there's no mastic and there's no tape on anything, but how many of my leaks are really to the outside because they're behind the knee wall in the knee wall attic? That's a good way to find out how big a problem that might be. Um, and so in a comfort diagnosis situation, that could be a good one to do, especially if you're already going to do a blower door, and if you're already going to do a total duct leakage test. Well, it's 5 more minutes to do the the duct leakage to outside.
It's a no-brainer.
Yeah.
Um Yeah. So one other thing I wanted to mention is a lot of this is we use air to move BTUs. Air is the vehicle to move BTUs from one room to another, or from the equipment to the room that we need to heat or cool, right? So
Yeah.
duct leakage is so important. I think there's so many residential contractors out there that don't do new construction. They don't install ducts from scratch. So they don't know how tough it is to seal a duct system. They're not testing the leakage rates, right? And I've just recently I designed a system for a low load house near me, and
Hmm.
a local contractor installed it. All the ducts are inside the conditioned space, and they taped everything.
Yeah.
And then he paid somebody to come out and do a duct leakage test, and they had like 250 CFM of leakage on a 1,000 CFM system.
Hmm.
But they're like, we taped everything. We don't understand. It's a methodical process that you have to figure out, and it's not as easy as just slapping tape on there.
For sure.
There's science behind it, and it does make a drastic impact. And that's one of the things I wanted to mention too. Is I think the popularity of mini splits and those type of systems where people are not able to solve these issues, these airflow issues. A lot of it is duct leakage.
Yep. Yeah.
You know,
Exactly. So put a mini split in the bonus room. How many times have you heard that suggestion?
yeah,
Right. And bonus rooms are especially bad because, like we just talked about, the leakage can be outside behind the knee wall attic. Almost zero insulators and construction companies know that you have to seal the floor cavity below the knee wall, or it leaks between the attic and the house. The other thing is that when somebody's not doing a load calculation correctly, they're just using square footage. Like, oh, every bedroom is 100 square feet. The bonus room's also about 100 square feet, so it gets a 6-inch branch as well. Okay, except all those bedrooms, they have like 2 or 3 exterior walls. The bonus room has 5 exterior walls and a big window at the end. Um, so they get the load wrong, and then the branch run is too long because it's always, the far end of the house from the furnace. And so you're not delivering the right amount of air. It's a leaky structure anyway. So if you do your blower door test, like, oh, blower door test came out at 2,000 CFM. Well, 800 of it might be the bonus room. It's a big chunk of it that's in that one bonus room, or in the half story if you have a 1.5 story house. So that's bonus rooms and half stories are uniquely challenging. Um, and you gotta, the mini split is not a good solution to my mind, because that's just going to cost you more money forever to heat and cool that space. If you know, find a weatherization contractor, a good insulation contractor, and have them air seal and insulate that space properly, and then you seal up the ducts that are going to it, you might find that it's a little less comfortable because we're still not getting quite enough air, but it's way better. And now you've lowered your bills forever instead of raised your bills forever.
yeah, and well, I think a lot of contractors also think about, well, I could make money by installing a mini split. You can
Yep.
make money, but if you're looking
Yeah.
out for the best interest of the customer, right? Now
Yeah.
you're making them maintain two separate systems. They are forced to maintain two separate systems for the life of their where however long they live in the house. And then also not only maintain, now they have two separate systems that they will eventually have to replace again,
Yeah.
which you could just spend the money up front to try to fix the problem instead of addressing
Yeah.
the symptom, you know?
Yeah. Yeah. And it depends on the layout. It might be super challenging to add another branch into that bonus space, even if it gets air sealed and insulated. So it's I'm not saying it's never the right solution, but like you said, they're now getting on the hamster wheel of paying more for operation and paying more for maintenance and paying more for system replacement for a long time. you know,
Yeah,
they easily would pay for that air sealing and insulating if you can find the right person to do that.
absolutely. So did we miss anything? I know we covered a lot.
Let me make a plug for weatherization. because a lot of NCI contractors are really doing great stuff with home performance, with understanding high performance systems, but don't want to get into air sealing insulating. And that's totally understandable. That's a big reach. But you should know that every county in the United States gives money for weatherizing low income homes. And the people that work in those programs will often just do private work as well. And I think funding has been reduced, so you might find that some of those people would be really interested in doing some private work, and their prices are often more affordable than you might think. So it might be, I just quoted $8,000 to put a mini split in the bonus room. Well, the weatherization guy only wants 3,500 to air seal and insulate that same bonus room. And I think I can get a little more air in there if I do some balancing and push more to that bonus room. So that might be a really good solution. So learn who's doing weatherization in your area. They're super knowledgeable. They might be more affordable than you think. And that'd be a good partnership for you to have when you find out that you can't HVAC your way out of a bad house. You need to have a partner who knows how to fix that house. And that could be just a huge win for your company. You could become, the go-to guy in your area that says, where people go, oh, you call this company because they know how to fix this kind of problem.
Exactly. One other thing I wanted to mention too is not just the a weatherization company, but like if you do have to run a duct, from what I found, when I still had my company, I found a decent drywaller that charged reasonable prices.
Mm-hmm.
And when you approach a homeowner and you say, I need to cut open this wall, this ceiling, and this wall over here to run my duct, and we'll run it, and then good luck fixing everything.
Yeah.
They're like, yeah, no, I'm just gonna live with it or whatever. They're not really inclined. They're overwhelmed. Everyone thinks like drywall repairs are big deals,
Yeah.
but in reality, drywall is cheap, right? So
Mm-hmm.
if you partner with somebody and you quote them, and I'm going to fix this duct, I'm going to change the size of this duct or add another branch run to this space, and we will close this up for you. I'm going to close this up, and will be primed, and all you're responsible to do is paint it when you're done. That's like a turnkey solution that people are like, oh, that's not a big deal, you know?
Yeah. And so at least I don't know how it is broadly around the country, but at least the weatherization guy that I've used before on personal projects of my own, who also is the guy that appears in our video about weatherizing a home, he'll do drywall too. So if he has to cut something open to access, to air seal, to blow in insulation, he'll do that, and then he'll patch up the drywall too. So
Awesome. Yeah, turnkey solutions, making it easy.
yeah,
Well, Steve, I got to tell you that as usual, I really enjoyed talking to you. I learned something. One of the things I haven't tried is using a pressure pan while running the blower door. And that's one of the first things I'm going to do the next time I set up my blower door. So I'm
awesome.
looking forward to doing that. But thank you so much for your time. And as always, I look forward to seeing you soon at the symposium and at HR. So,
Yeah, awesome. It's been great. Been a lot of fun. We'll keep talking.
yep. Take care, and I will see you in the next one.
All right. Sounds good. Thanks.